45. The diagram below represents a setup for demonstrating motion. When the lever is released, the support rod withdraws from ball B, allowing it to fall. Okay, and at the same instant, the rod contacts ball A, propelling it horizontally to the left. Which statement describes the motion that is observed after the lever is released and the balls fall? Neglect friction. So let's draw, roughly speaking, the trajectory of each of these. So A is being propelled to the left, but of course gravity is going to pull it down to the tabletop, so its trajectory would look something like this. Right? That's roughly the path that it's going to take. B is not being pushed to the side at all. It's just going to be released, and it's going to go straight down. Alright, so that's the path of B, and that's the path of A. So which of these is true? Ball A travels a constant velocity. That's not true, right? Because it has an initial constant velocity in the horizontal direction to the left, and it will continue to have a constant horizontal velocity, but it's accelerating due to gravity pulling it toward the tabletop, and its direction is changing. So velocity is a vector, so if that direction keeps changing, then its velocity is changing, so that can't be true. Ball A hits the tabletop at the same time as ball B. That's actually true, because both B and A are being released at the same instant, and even though A has some horizontal velocity, that's completely independent of its vertical velocity. Vertically speaking, they're both at rest, right? They both have no vertical velocity at the moment they're released, and the acceleration due to gravity can act upon them equally. So they'll both go down at the same speed, so 2 is going to end up being the best choice. Let's see why the others don't work. Ball B hits the tabletop before ball A. It's tempting to think that because A has to travel this extra distance because it has that horizontal component of its velocity. But again, like we said before, the horizontal can be taken as completely independent from the vertical. So while it's moving along to the left, it's still being accelerated downward by gravity exactly the same way as B is. So 3 is not good, and B travels with increasing acceleration. No, B is being accelerated due to gravity. It travels with increasing speed, but it's constant acceleration. It's a constant acceleration of 9.81 meters per second squared, which are increasing its velocity, but its acceleration is always 9.81 as long as this experiment is being done on Earth. So 2 is the best choice.